Hello, this is a two-part tutorial on modeling a room interior based on diagrams, and then surfacing that space with shaders and lighting to match photographic sources. We start by putting the diagram into the background. If you are using Max 2013 or earlier, you can use Alt-B to hit Use Files, Match Bitmap, and then Lock Zoom Pan. Lock Zoom Pan is not available in Max 2014, and so you are limited then to putting an image onto a plane in the background. Once you've chosen your image, apply to all views, and hit OK. Turn off the grid. And then in the perspective view, I will start creating boxes. My purpose here is to create each of the walls as a box. And the boxes do not need to be particularly thick. Often a thickness of 5 is sufficient. I also tend to like round numbers, so I would tend to make this 130 and 95. This diagram is a nicely detailed diagram by artist Sarah Jordan. Notice that each of the doors and the windows are drawn, but also the door frames and the window sills, and even the baseboard for each room. All of the major details on the walls, the electric sockets, the windows, everything that would be on the walls. And in the floor, we can see outlined diagrams for each piece of the major furniture. In this case, we're assuming the furniture was made prior to building the walls, and each of those will be merged, and then to make sure that they fit correctly into this room, it's really good to have the floor plan so we can size them properly. Alt-X allows us to see through the blocks, and we can duplicate. I'm going to increase the divisions here, and once here, and once here. This I'll now convert to double poly, so I can drag down this line for the baseboard and do the same here. And then these lines I'm going to use for getting the angle. I can get rid of this line with Control Backspace. And to make sure I'm working with quads, I can then cut out this triangle. Duplicate, rotate 180 degrees. Duplicate. For the floor, I don't need a box. I can simply use a plane, but it is very important that all the walls and the ceiling parts be boxes, boxes that will never be attached to each other. They will be simply able to intersect, but they have to be boxes because any exterior lighting needs to be blocked by actual thickness in the walls. So for the ceiling, I can copy another wall box. And extend it to the right size. Actually, I don't need a baseboard. I double-click that line, so it selected the entire segment all the way around. Here I have the piece of the wall that would fit into this angle. Over here is the piece of ceiling that would fit on this piece of the wall. And now that I have all of the pieces, I can start cutting in the windows. Alt-X to remove the see-through, the X-ray. To create all of the windows and doors, we will start by cutting and extruding the door frames and the window sills, and then use Boolean to cut out the major shapes, and then, of course, target weld to clean them up. We'll start in this front room. I'm going to isolate this block, select the geometry, and use Slice Plane to cut in the major lines. In the front view, I will lift this up to get the very top of this door frame, slice, and then rotate this 90 degrees on the y-axis in the user view to get the two vertical lines, slice and slice. I can now take a few moments to quickly target weld all of these loose vertices. We always want to try to have quads. And the next step is going to be to differentiate, in this case, between the door and the windows. There's this space up here. I'm going to select these two edges, F3 to see through it. I will use Connect to draw a line, and then raise that line up, I think to about here. Now you'll notice what looks like an inset space for the windows. So I'm going to select this piece of geometry right here, and do an inset. So this line matches the door on that side, this line matches the door on that side, and then I can use bevel to create a slightly beveled in. I used the word inset before to mean beveled in, as opposed to the inset tool. And that way the windows will have a visually distinct space. Now all of this door frame and this baseboard down here need to be extruded. So I will hit bevel for an angled extrude, and I want it to come out maybe just 0.5. This is the distance of the baseboard, and I want an angle very, very small, maybe even only 0.2. That would be 0.2, negative 0.2. The slightest bit of angle so that we don't have a terrible 90-degree angle. 90 degrees creates invisible extrusions. This way we have a very, very slight extrude using bevel and a slight beveling of negative 0.2. Hit check, deselect the baseboard, and all the rest of this can come out again. Another 0.5, another negative 0.2, hit check. And now the door frame is more than the baseboard. To actually get the door and the windows to be removed, we will Boolean. Start with the box. Give this box 0 height. Segments, but significant height for the door itself. And to save time later, I can now duplicate this to create an individual window. Pretty good. It's intersecting, so it will create a good Boolean. I will now duplicate one at the opposite end. Work my way to the middle, trying to space them evenly. Of course, I could use an array to get an exact spacing that's even. In this case, I'm okay winging it a little bit. That looks relatively even. And remember that for Booleans, you always get better results if you can manage to have as few Booleans as possible. So instead of doing these 6 plus 7 plus 1, 7 boxes individually, I will attach them. I've converted this first one to editable poly, and now I will attach all these boxes. I go to the Create panel, Geometry, change from standard primitives to compound, make sure I have the wall selected, hit Boolean, pick operand B, click on the objects, and then hit Boolean again to automatically draw in the quad lines. And it did a pretty good job for most of the quad lines. It missed a few up here. We convert to editable poly, select all the vertices, hit weld, and then see if it will let us cut some of these lines. We always want to have quads. We want lines that we control and define. If I click here, it might not have let me draw all the way across in this case, but it will let me target weld. Backspace didn't work, but I'll be able to target weld it in. And that's how it's going to let me draw that line. So I click cut, instead of trying to go all the way across, which it might not do. In this case, I'll just cut to here, release, and target weld. Cut, cut, target weld. A couple more. Cut, cut, target weld, and cut, cut, target weld. And there we have one of the walls. I might decide to select both the top of these baseboards and drag them down a bit more for a more obvious bevel. But otherwise, that looks pretty good. Hitting F for front, we build a door. Starting with a box, and then doing a Boolean. In cases like this, I like to have two boxes that are instances of each other. So as I increase one, I can also see the corresponding increase in the other, and I can be sure that I'm really filling the width of this space. Let's give them both 29. Better a little bit of overlap than a gap. Each of them can go higher. And the reason why it's better to have at least a little bit of overlap than a gap is because light is going to be coming through the windows. We really don't want it coming through the sides of the door. That would imply a very flimsy home. This can also be just 5 in its width. Go a little bit higher to compensate for the baseboard. And now I can delete one of these, and then create the glass windows, or specifically the holes. Change the color of this so it's less easy to confuse. And decrease the height. This door has the same inset window shape that we had up here above the doors. So I'll start by converting the door to editable poly, selecting the entire front face, and doing an inset. Hitting the number 2 on the keyboard for edges. I can bring these edges in and surround my windows as evenly as I can. And then do a slight bevel inward. -1, and maybe only 0.5 for the width. And now if I click one of these boxes, convert to editable poly, and attach all of these other green window boxes, I can select the door. I can go to Create Geometry Compound Objects, Boolean, and pick operand B. Convert to editable poly. And now the doorknob. I'll do another inset. Scale this one way down. And flatten these lines as well as these lines. until I have what I think is a pretty good estimate of the structure from which the doorknob will be extruded. This can come out with a slight bevel. And then to extrude a round shape, I will start with as close as I can to a square. Select the vertices at the corners, and then chamfer. Once, deselect these extraneous vertices. Twice. Target welds the extraneous vertices. And if I don't think I got a perfect circle, I can select this slightly circular shape, apply the Modify Spherify. It will give me a much closer to a circular shape, and I can right-click, convert to editable poly. The Spherify will be baked in. And then I can bevel out. And now that one wall has been completed, we move on to the others using essentially the same techniques. For a curtain, we can use spline. We draw the number of curves that we want to see. And then we duplicate this twice. Once for where the sash is going to catch, and once at the very bottom. These bottom two now need to be rotated individually 90 degrees. And then the vertices can be moved and cross-sectioned with the others in order to create the final form. I'll select all these vertices, and I will non-uniform scale them together, making sure to set my selection to the center so that they actually move together and I don't simply scale the handles. It could be a little bit wider. And this one can also be at an angle. So now, if I start at the top, attach, apply the cross-section modifier as Bezier corner. I can right-click to convert to editable spline. And I can adjust the handles in order to get a result closer to the real curves. In Max 2013 and earlier, to change the gizmo to be selectable and non-selectable, it's called disabling the gizmo. This is the letter X on the keyboard. Evidently for Max 2014 and after, that is Shift Control X, because X is now a search function. If we apply the surface modifier, we can more easily see what the result is going to look like when it's finished. Showing result lets us see the result as we're working. That's pretty good. And now we could add a sash. One way to do that could be to get a rectangle with a little bit of corner radius, and not a lot of width, like that. Hitting Z to zoom in. This can be a little smaller. Reduce the corner radius by half. now, I'd like to try using a loft to give this thickness. So I will create another rectangle right next to this one. Give it also a little bit of a corner radius. Not so much thickness. Create geometry compound objects loft and get this shape. Not a bad start. Because these are instances of each other, we can make some adjustments. For example, if this hash is too thick, and I think it is, shrinking the shape will shrink the thickness of this hash. That looks pretty good. I'm going to delete the shape and the line, and all I have left is the loft, which I can adjust further as needed. For example, just to save on polygons, I can go to skin parameters and reduce my shape steps significantly. As well as my path steps. To create the bar up here, I could create a cylinder. That was started in the side view. And now it can be increased in height to extend across. Probably want it a little bit thicker. I'll give it a full one. No, a bit too thick. 0.8. And the diagram is not completely clear about the shape here for the endpoints, but I'm going to guess that I can get a reasonable facsimile, at least for our purposes today, by drawing out the shape. That looks reasonably decent. I can even just apply a modifier called bevel, which has 3 levels of extrusion called the height. And this way I can still adjust the shape later as needed. Make an instance. And perhaps I get a bit fancier with this if I made this only 0.5 and allowed it to have a little bit of an outline. Maybe 0.2, positive 0.2, and then add these other 2 levels. This could be another 0.5, and this could be negative 0.2, and in the middle, this could be another 0.5. And so it has some more roundness to it, more form. And I can curve those sides. Smooth across the levels. That's what I'm looking for. And shove that in. It looks like there's some sort of sash work up in the top, or perhaps it's simply surrounding the form. What I think I will do here is use Connect Refine to go across the entire top. Right click. Selecting every other one, let them pull out. And then these can be used for more curving outward. So these can start by going in. And then on this XY plane, curve these out so the cloth appears to go around the pole. I could certainly spend more time on this, get a more precise result, do some research. But for our purposes today, doing a quick example, that's pretty decent. To create this sconce-like shape, I'm going to use a lathe. I'll move the pivots into the center of the shape that I want formed. I apply the modifier lathe, L-A-T-H-E, and then I set it to only do 180 degrees. And I rotate 180 degrees. Since we want to avoid applying a non-uniform scale to an entire object, we can do it simply at the sub-object vertex level. Get the same results, but no change to the x-form on the object. Now that we have all the pieces of the room, we put them together into a box. I will start by rotating the floor and then positioning the walls around it. I find it useful to actually use the origin of the world, 0, 0, 0, for the location of any major scenery. So I've located the ground plane there, and I'm building my room around that. This wall I'll rotate 180 degrees. And lift up onto the 0, 0 plane. This wall and all of its pieces get rotated 90 degrees on Z. But first I need to make sure that it's rotating from the center of the selection so that it all rotates together. The slightest bit of overlap is sufficient. That will block out the light from outside. Same with this wall, except rotating negative 90 degrees. And I line it up with the first wall. The roof, in this case, is at an angle. And again, I want some slight intersection to be sure that it will block out the light. And then I have these two pieces. And now, standing inside the room, all the pieces are in place for the structure of the walls. The next stage is to merge in all the furniture that has been made for this project. I have, before this demonstration, whipped out some very simple examples of all the furniture for this particular room. We go to File menu, Import, Merge. Merge allows us to bring objects from other files into this one. Here I have the various pieces, couches, tables, and some of the things on those tables. Most of which are currently the wrong size. All these pieces that are currently selected, I'm going to create a layer in the Layer Manager for all of the furniture. Which allows me to hide them until I'm ready to use them. I will select all of the walls and put them in a layer called Walls. I will move this check mark up so that anything new that is created goes into 0 default and not into these hidden layers, which would result in the new object not being visible. I'll make the walls visible again, select just the floor, and put that into furniture. I selected the floor, I selected the layer, and I hit the plus button. I'm going to select the ceiling and create a new layer just for ceiling. since I'm going to want to be able to hide and unhide that very easily. Now I will hide the walls and just unhide the furniture. Hitting T for top, scale each of my objects to fit this top view before moving them over the actual floor plane. So this is the table, and I will scale it to fit the table. Here are the chairs that go around that table, and I will scale it to fit. And then rotate. This is an end table. Meant to fit here. Here is a couch. The smaller of the two. Again, these were very, very quick, rough models, not as detailed as one would expect to fit with the rest of this room. Another couch. This lamp should certainly be smaller. I'm working from knowledge of the photographs for the moment. But there is a lamp here. Here's the table that goes in the middle of this room. And here are a bunch of items that are meant to go on top of this end table. I'll simply scale them together for the moment and put them in this area. All these other objects, I'm going to right-click on the Move, Transform, and give them all the same Z position, which, if their pivots are at the base of the object, will move them to the ground. Here's the one object that did not have the pivot at the base. It is helpful to have the pivot at the base so that when the object is scaled, it scales up from the ground. It doesn't need to be repositioned onto the ground. I'll make a duplicate of this chair as an instance. And rotate it to match the position of this other chair in the diagram. And here we have the pieces. Since the diagram doesn't show me where all of these pieces go on the table, I'm just going to get them on the table for the moment. When we compare to the photographs, we'll be able to be more accurate. Here is a picture that also goes on this table, rotated to face the rest of the furniture. Okay, so all of these pieces can now be moved into the room. Very good. Now we can unhide the walls, select a central object, hit P for perspective, Z to zoom in, and we can use this central object as a pivot point for looking around the room. I have to zoom in a bit so I'm not Everything's interrupted. And we can see where the furniture is beginning to intersect the walls, so it probably needs to be moved a little bit further out. If we select the furniture layer in the Layer Manager and hit Select Highlighted Objects, we can move them all at the same time to pull them out of the way of the furniture. Here at this big wall, I believe there's supposed to be a door that I did not build. But now we have all the furniture placed.